Hello everybody and welcome back. Let's talk about the problem best time to buy and sell stock. In this video solution, I'm going to go over all of the 6 problems in the series of best time to buy and sell stock, and I'm going to use just one single approach to solve all of them. That's correct, just one approach. Now, before we jump into the solution, this is sort of the dependency graph of all of these problems. And the first thing we're going to do is start off with the problem number 2. Once we do that, we can try out these fee transaction variation as well as the cooldown variations. Then we'll go on to the 1, 3, 4 chain. This is sort of the layout of this entire video, and the timestamps will be present in the description. Again, the only thing that I'm going to promise to you is that you will be able to solve all of these 6 problems by using one single approach. And don't worry, I'm also going to present to you the intuitions, the observations, and the core logic that you need to figure the solution out yourself. Okay, super excited to bring you this one, so let's get started. Before we get all of the 6 questions accepted, we first must understand the input-output format. And this is sort of the general structure that is going to be consistent across all of these problems. You're given prices, which is going to be a list of integers. They basically specify how up or down the stock price goes. At time equals to 0, the stock price is 1. Then it goes up to 2, then 3, then 0, and then 2. So there is a graph-like thing that forms. The goal of this problem is to maximize the amount of profit you can get from buying and selling the stocks at these particular times. So you have to figure out a good strategy that can maximize the profits. Okay, for this particular test case, this is the answer. We'll buy the stock at this point of time, taking the cost of 1. We'll sell it over here at the profit of 3. So the total profit we have is 2. Then we'll buy it here again, and then we'll sell it here again, giving us a total profit of 2 over here for this transaction and 2 over here for this transaction. And so the profit is 4. Pretty simple, right? Okay, let's talk about the constraints. And this is where things will start to get a bit more interesting. The first thing we note is that the stocks, the amount of stocks in your inventory or your portfolio, can only be 0 or 1. It's always binary. So you can either buy one stock or you can sell one stock. You can't buy 2 or more stocks. You can't sell 2 or more stocks, right? You can only have 0 or 1 stocks in your inventory. This is an important constraint. Okay, what's next? As we saw before, in this case, we bought the stock at some points of time and sold the stocks at some other points of time. Buy and sell were 2 particular actions we could take at any single point of time. And that is what the question will have you believe. But that is not the complete picture. You see, because buy and sell are indeed 2 correct actions, there is one action hidden here. See if you can take a guess. There is one action we're still missing. That is the action of hold. See, while we bought the stock at this point of time, we held our market position. We still held our stock with us for this time. And only then at this point of time, we sold the stock. So we don't actually have 2 operations. We don't actually have 2 actions, buy and sell. We have 3 actions. We have the action buy, sell, and hold. This is the first key observation to solving all of these problems. Now that we understand this, I think it's finally time to talk about some simulations as well as understanding the core logic of this problem series. Alright, to understand the solution better, I'm going to present to you this visual over here. On the upper side, you see a graph of price versus time, which represents the prices of the stock as time passes on. So for time equals to 0, price equals to 1. Time equals to 1, price equals to 2, so on and so forth. Now, according to these stock prices, we have to make decisions, which is the bottom part over here. At every single point of time, I have 3 decisions that I can make. I can either buy the stock, I can either sell the stock, or I can hold the stock. These 3 decisions are very important to understand, and how we take these decisions, how we make these decisions is going to play an important role in maximizing our profits. Let's track the variables on the right hand side over here. Okay, what happens when time equals to 0? When time equals to 0, we start off with the number of stocks equals to 0. Right? We don't have anything in our inventory or our portfolio, So we'll start off with time equals to 0, s equals to 0. What are the options? What are the decisions we can make at this point of time? I can either buy the stock or I can hold the position. I cannot, and I stress, I cannot sell the stock. Why? Because I don't have it. You can only sell the stock if you have some stocks. And we see that the number of stocks with us is 0. So I can't really sell. So while we do have these three options available with us, the only two valid options are either buy or hold. Make sense? And I've written this orange and yellow over here. Now, here is sort of the key understanding of this problem. Which one should I pick? Should I go with the buy option or should I go with the hold option? At time equals to 0, I don't really know which one to pick. How do I make the decision whether to buy or hold when I don't know what's going to happen in the future? We somehow need the ability to look into the future. Because if I know that the stock price at time equals to 2 is going to go up, then it is a good idea to buy it right now. But if I know it's going to go down, well, it's best to not do anything and hold the market position. Make sense? So somehow I need to have this information coming from the future that is going to affect my decision making at the present point of time. Somehow I want to look into the future to understand what to do right now. Make sense? This is where recursion comes in. If you've been following my channel for a while now, you'll realize that this is indeed where we'll use recursion. Whenever we have the option to make a couple of decisions from the set of decisions, in this case 3, I don't know which one to pick, but I can look into the future, figure out which one to pick, and I can make the optimal decision. We'll use recursion, and if you don't understand it well, the code will explain it better, and we'll come to that very soon. But for now, let's try to continue further and simulate and see what happens, right? It will give us a better understanding of how the problem actually works under the hood, how the recursion works under the hood. So at this point of time, I have two options to make, right? I can either buy or hold. Let's say that I make the decision to buy. Okay, one of the possible cases is I make the decision to buy. What happens next? When I've made the decision to buy the stock at time equals to 0, at time equals to 1, what options do I have now? Can I buy the stock again? I have still three options: buy, sell, and hold. But what are the valid options? Can I buy the stock? I cannot, because I already have the number of stocks with me as 1. Make sense? I already have 1 stock with me, and the number of stocks in the constraint, recall the constraint, was either 0 or 1. So I can't buy a stock again, but I can either sell or hold. And so we see this again decision over here of either we can pick the green one or the yellow one. Again, I don't know which one to pick, so let's just pick one randomly. Let's say that I decided to sell the stock. Now at this point of time, again, I have to make a decision. Do I buy or do I sell? Because now the number of stocks available with me is 0. Remember that we sold the stock over here, so the number of stocks is again 0. At this point of time, what options do I have? Buy or hold, right? I can't sell because I already have 0 stocks. So selling is not an option. And this is why I've marked it with orange and yellow. And so now I think you have a better understanding of what's going on. At every single point of time, we are going to make a decision. We're going to make one of 3 decisions: buy, sell, or hold. And just to formalize this, for every single point of time, recall how we had the stock variable with us as well. It's not just the time that is important, but the amount of stocks as well, right? It's somehow the unique combination of the time and the stock that really matters. That is going to help us define which of these options we should pick. Make sense? And again, just to formalize, when the number of stocks you have is 0, you can buy or hold. When the number of stocks equals to 1, you can hold or sell. When the number of stocks is 1, you can't buy, and when the number of stocks is 0, you can't sell. Pretty simple, pretty obvious. In fact, this is the entire solution for buy and sell stock too. Let's go ahead and code that up, and we'll soon go on coding all of these up line by line. Let's get started. Oh, just by the way, if you want a return version of all of the explanation that I just did, with all of the visualizations completely explained with the logic I took, everything is present on my website and I'll put this link down below. You can feel free to go over that, and you can also find all of the codes over here. Anyways, yeah, let's get back to coding up best time to buy and sell stock too. Okay, let's code up the solution for best time to buy and sell stock too. The first thing we're going to do is write down the recursion function. And what did we note for the recursion function? Well, we realized that the recursion was just a unique combination of what current time step we are at, as well as the number of stocks in our hand. And that is going to determine which action should we take. Okay, so let's go ahead and write down time and stock. Now I'm going to return the maximum of buy, sell, and hold, because at each point of time, our entire goal is to maximize the profit. So I'm going to return the maximum of all of these values, of basically saying that what happens if I buy the stock at this particular point of time. What happens if I sell the stock at this point of time, and what happens if I hold the stock at this point of time. I'm trying to simulate what happens next, and whatever gives me the maximum result, that is what I'll return. Let's also write down these: buy, sell, and hold. Okay, so what do we do when it's the time to buy a stock? Okay, so at this point of time, what happened? We saw that the only two options available with us was to either buy a stock or hold the position. We can't sell the stock because we don't have any, right? And so we took the decision to buy a stock. What did that mean? Right? Buying a stock, what does that mean? Buying a stock means that I'm going to encounter a price. I have to pay out from my own pocket a prices of time. For this particular point of time, I have to pay this amount of money, and we'll write it as negative because this is the total amount of profits I'm getting when I buy the stock. So it's negative here. And I can do this, and I'm going to say plus recurs of time plus 1, stock plus 1. What does this mean? This means that, okay, you know what did it mean when I bought a stock? When I made the decision to buy a stock, I am going to encounter this amount of price. I have to pay this amount of money. And now that I have the stock with me, I'm going to increase this counter, and I'm going to look into the future of what it is going to happen. If I make the decision to buy right now, I'll try to simulate what happens in the future if I made the decision to buy. That is exactly the simulation as we saw before. Right? We made the decision to buy, and we were trying to see what all decisions we could make after we have made the decision to buy. This is all we're trying to do. Very simple, very, very simple. Now this is one possible case, and what is the case? And like the question we want to ask is, when can we buy a stock? When can we buy a stock? We can only buy a stock if the amount of stock is 0. Else we'll say set it to some default negative value, some negative infinity value. Okay. Then we'll say what happens when you want to sell the stock. Now this is going to be a lot of copy paste. What is the decision? What happens when you make the decision to sell a stock? Whenever you make a decision to sell the stock, what are you going to get? You bought a stock at an earlier point of time, and you're going to sell it now. You already have the stock. You're going to sell it now. What is the amount of profit you're going to get by selling the stock? This is just prices of time. Then you'll do the same thing. You'll do recurs of time plus 1. You'll say that, okay, I have sold the stock now. What will happen in the future? You're asking the decision. You took the decision to sell the stock, and now you're asking the question, what will happen in the future if I sell the stock right now? Okay. The stock, instead of being plus 1, will become minus 1 because you've reduced your stocks by 1 because you've sold the stock. And you can only do that if the number of stocks was 1 previously, right? This is the formalization we saw over here. Cool. So what about the holding case? In the holding case, you aren't really interacting with the market, so you don't really get any prices, positive or negative. But you still have to recurse into the future. So we'll say time plus 1. What is the amount of stocks that you'll send into the future? Again, at this point of time, when you're making the decision to hold, you're trying to say, what happens in the future if I hold right now? Okay, so time becomes +1 and the number of stocks is going to be passed as is. We aren't increasing or decreasing because we haven't interacted with the market. We have taken the decision to hold our position. Okay, cool. We're pretty much done. What's the base case for this recursion? Let's go back to this. When does this recursion end? You make a decision to buy, fine. Then you make a decision to sell, that's also fine. And then you can keep on going up till the point where the prices of the stock are no longer available. Basically saying that if the current point of time is greater than equals to the length of prices, then we can return 0. Because after that point of time, after you've reached the end, you can't make any more profits. So the maximum amount of profits you can make after this point is 0. That is why the base case is 0. Let's go ahead and return the recurs of time equals to 0 and stock equals to 0, because we are starting our journey from time equals to 0 and s equals to 0. Cool, let's try running this code. It shows accepted, but before submitting, I want to also present to you one more interesting detail. There may be cases of repeating subproblems. Let's take the case of this particular chain of reasoning. Let's say that one of the decision paths we took was first to buy, sell, then hold, then buy and sell. This is one possible case. This is one possible entire branch of the decision tree. But there is another possible case, and in fact there can be multiple ones, but I'm going to show one more. There is one more case where we buy the stock, then hold, and then sell. And then we buy and sell again. What do you notice is the commonality between both of these decision branches? We see that the B and S, this thing is getting repeated again and again. In fact, there can be many more cases of overlapping subproblems. This is why I will use dynamic programming over here. We have the case of overlapping subproblems. We have the case of these paths being repeated, which means that we can save the results for whatever happens in this path, and we can save that and then reuse it later on. Okay, let's go ahead and write that down. And this is just going to make our solution much faster. I'm going to use something called the LRU cache, and I'm going to set it to none. We'll go and run more sample test cases, and we can finally submit this. Cool. So we get accepted with the runtime of 112 milliseconds. So now that we're done with the best time to buy and sell stock 2, we can move on to 2 more variations. Going back to the dependency graph, we see that once we've solved 2, we can now go and try to solve this fee question with the transaction fee. And we can also try this cooldown thing. So let's go and first try out this fee thing first. Just a quick aside, again as a reminder, everything down from the problem structure as well as the logics, intuitions, the simulations, and even the codes, everything is present on the website. Links in the description below. Okay, so the difference between the best time to buy and sell stock 2 and the best time to buy and sell stock with transaction fee is that for every transaction, you may complete as many transactions as you like, but you need to pay the transaction fee for each transaction. So every time we buy and sell, which is going to constitute one transaction to buy and sell, we have to encounter some amount of fees. So what I'm going to do is something very smart. I'm going to copy paste the entire thing, and we're going to make one small modification. See, a transaction consists of a buy and sell action, which means that whenever I'm selling, I can add this minus fee cost to the total profits. And this is the only difference I'm going to take. And let's go ahead and run some sample test cases, and we'll submit this as well. Again, this got accepted with this small little line of code. This is it for the solution of best time to buy and sell stock with transaction fees. Okay, it's going to get crazier, by the way. I'm going to copy paste this again. Sorry, I'm going to take this again. And now we're going to solve best time to buy and sell stock with cooldown as well. Look at how simple life gets. So the only condition and the constraint here is that after you sell your stock, you cannot buy the same stock the next day, which means that there is some amount of cooldown time hidden here. So earlier we could sell, we could get the profits, and we could return with time plus 1 and stock minus 1. Stock minus 1 was to sell the stock, basically reduce by the count of 1. And time plus 1 said that I'm going to look into what happens in the next time step. But cooldown says that you have to wait one more day. You have to take a hold action forcefully the next day. Okay, what happens in the hold action? The only thing hold action does is increase the time by 1 and pass the stock as is. So what we can do is very sneaky, super sneaky, what we can do time plus 2 over here. That is the only change I'm going to make. I'm just going to convert time plus 1 to time plus 2. Now we're going to run some sample test cases, get accepted. Okay, we'll submit this. What time am I exceeded? No. Oh, I didn't put LRU cache. Cool. We'll slap on the cache here, make it more efficient, make it a dynamic programming problem, and submit this. Cool. Finally, it gets accepted. So we're done with the best time to buy and sell stuff with cooldown as well. Now we want to solve this chain of questions, which is going to be 1, 3, and 4. Okay, so the first thing we'll do is we'll try to understand what is the commonality between 1, 3, and 4. The first thing we see is that in best time to buy and sell stock 1, we have a constraint that we want to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. This is somehow restricting the total number of transactions we can do. Earlier, in best time to buy and sell stock 2, with transaction fee and with cooldown, we had no such restriction on the number of transactions. We could do as many as we liked. But in this case, we have a restriction that we can only make one single transaction. Now, when it comes to best time to buy and sell stock 3, we observe that the constraint here is just slightly modified, saying that instead of you are being limited to one transaction, you can do at most 2 transactions. Similarly, in best time to buy and sell stock 4, you're given this K and you can do at most K transactions. So all of these 3 questions are similar in the sense that if you can find the solution for K transactions, you can basically set K equals to 2 in this case and K equals to 1 in this case. Very simple. Let's talk about K thing and how can we now incorporate the information of the number of transactions into this recursion function. Let's talk about finally the transaction modification. Earlier, we had a structure like this. We would recurse having this unique combination of time and stock to determine which action to take. And we would determine what action to take at every time step and get the total amount of maximum amount of profit from it. Now we want an additional parameter in this. We want to include the information of counts. Counts being the counts of the transactions. And that is all. The only thing we're going to change is add an extra parameter which keeps a track of how many transactions have been completed up till now. That is all. Let's get started with the code for best time to buy and sell stock 1. We take the code from best time to buy and sell stock 2. I'm going to take this and we're going to modify it slightly. This is going to have a third parameter count, and so will this, and this will have it. We'll also want to initialize it with 0 over here because the number of transactions we start off with is 0. Now, what constitutes a transaction? A transaction is a buy followed by a sell operation. First, we needed to have bought the stock somewhere earlier in the future, and at the later point of time, we could sell the stock. This means that whenever we sell a stock, we have to increase the number of transactions we did by 1. And this is in fact the only thing we're going to change. We also must add this base case over here. Now this is an additional constraint. So you want to check if the count somehow becomes greater than or equals to the upper limit of count, which we'll call K. If the count somehow becomes greater than that, if the number of transactions starts to touch and go over the upper limit, we'll also return. Now what do we return? This case is just the exact same as this one, saying that once you have completed at most k transactions, you can't do anything else in the market, which means that you have to return at that point. And so we'll return 0, similar to this case. The only thing I'm going to set more is this k equals to 1, saying that we can have at most 1 transactions in total. Let's run this code and submit this. Great, so we have it accepted. Now we can move on to best time to buy and sell stock 3. The only thing that really changes in this question is the k restriction, which now becomes, instead of 1, to 2. I can directly go ahead and submit this, and we get this accepted as well. Finally, what I'm going to do is take this again, we'll put it over here, and this time the k is already specified, so we won't need to specify it again. This is the only change we're going to make, and let's submit this. Cool, so we have it accepted as well. And this marks the end of all of our questions. If you realize, we only made very small modifications after we have done best time to buy and sell stock 2. For the fee modification, we added a transaction fee over here. For the cooldown modification, we added extra time. When it came to best time to buy and sell stock 1, which had the upper limit on number of transactions, we added an extra parameter. Similarly, in the case of best time to buy and sell stock 3, we have this parameter set to 2. And finally, in best time to buy and sell stock 4, we have this parameter given to us already. Anyways, this is it for this video solution. If you like this video, it took me a long time, so liking this video will be a good feedback indicator for me. And if you want to see more of these long, high quality video solutions, subscribe. And as always, thanks for watching.